Olá pessoal, como vai? Tudo bem? Para quem não me conhece, eu sou o Diego Porta, sou Academic Advisor da EFIG e hoje temos aqui o professor Cole com a gente novamente para falar sobre engenharia civil, como se tornar um engenheiro civil. Fico muito feliz e muito honrado porque tenho um degree nessa área, sou engenheiro civil, então fico muito honrado com essa aula, estou ansioso para ver o que o professor Cole vai trazer para a gente aqui. Alguns recados. Galera, vocês podem abrir o microfone a hora que vocês quiserem para falar com o professor Cole. Quem não se sentir confortável em falar com ele, pode mandar uma mensagem no chat do Zoom ou para quem não tiver meu WhatsApp, vou passar aqui. Fiquem à vontade, mas vamos interagir com o professor. É, Tem um PDF que vai ajudar você no step by step, mas não é mandatório, tá bom? Não se preocupem. Eu, do mesma forma, vocês vão receber esse PDF por e-mail para vocês fazerem um assignment depois, ok? Então não se preocupem. Bom, é isso. Eu espero que vocês aí aproveitem mais uma mock class do My Way da EFIG em parceria com a Study Group e a Liverpool Hope University e com o professor Crow. Hi, professor. How are you today?
I'm good, thank you. Are you okay?
Yeah, I'm okay. Thank you very much. So
No
thank you
problem.
for joining us one more time and do your magic.
Okay. Right. Let me just get my clicker working. Okay. To everybody who has met me before, hello again. To everybody who's meeting me for the first time, my name is Carl Myers, and I'm the engineering project tutor for Study Group's network of international study centres in the UK. My academic and professional background is in the fields of civil, electrical, mechanical, electronic and robotics engineering, and also computer science. May I add also to those who have been in some of the classes with me before, you have requested more information from me and also more tutorials. I have experienced a little bit of, or a few technical difficulties my end, but I will be replying to them over the next day or so, okay? So I haven't forgot, I promise. Right, okay. So during this session or demo session, I will give a brief introduction of civil engineering and why you should choose to study this engineering discipline. I will give you some examples of the careers you may pursue with a degree in civil engineering. And of course, the most exciting part is where we together design a trust bridge in Tinkercad, which is an online platform for teaching you, the students, the basics of the product development lifecycle, which is design, simulate, and prototype. Hopefully, you have all had the opportunity to sign into Tinkercad. If you haven't, please do so, and I'll also give you a few minutes at the end of this presentation if you haven't already done so. Okay, so let's begin, and let me kick off with a question. What is civil engineering? Okay, civil engineering is one of the oldest, if not the oldest, of all the engineering disciplines. Think of the pyramids, the Colosseum in Rome, and the roads the Romans built, which we still use today. As a civil engineer, you will focus on the improvements of civil society. Let me just start this video for you. There we go. Okay, you will focus on the improvements of civil society. For example, building new roads to connect remote villages, building new hospitals, railways, and bridges. The list of what a civil engineer does is truly endless. Essentially, civil engineers are focused on meeting basic human needs and assisting people in their daily lives. To do this, they need to understand the environment and how they can use it safely and intelligently to improve the population's quality of life, thus ensuring that all structures and utilities that they implement are safe, economical, and environmentally sound. As a civil engineer, you will be taught the skills that are focused on understanding the environment and natural elements, coupled with expertise in construction techniques and design skills, allows civil engineers to work on massive skyscrapers, such as the huge civil engineering projects in Dubai. So why should you choose to study civil engineering as an engineering discipline? Employability. The world today is rapidly expanding, and with new initiatives in living and creating a more sustainable, environmentally friendly environment, civil engineering is experiencing a massive boom. And due to this, many countries are showing a skills shortage in civil engineering, and in many cases, all engineering disciplines. So, what do I mean by skills shortage? Essentially, there are not enough civil engineers for the jobs available. This means you have an excellent chance of finding a job in civil engineering right out of university, and in some cases, before you even leave university. And this is the main reason why civil engineers enjoy one of the lowest unemployment rates of any profession. And civil engineering is one of the top paid professions. This may not be your main reason to choose civil engineering. However, the main reason for working is to earn money to live. Starting salaries for civil engineers are amongst the highest for any university's degree. It's the same with any engineering discipline, to be honest. It is one of the highest paid professions, being an engineer. In fact, the starting salary for a civil engineer, for example, is up to £29,000. And this is only a starting salary, which increases substantially with CPD and experience. What do I mean by CPD, or continued professional development? Essentially, this means you will never stop learning in civil engineering. With environmental initiatives and huge expansion and development programs set to continue, and in many cases increase, you need to keep your knowledge up to date and relevant. And with this continuous learning comes an increase in salary, i.e., the more you know, the more you earn. Global opportunities. Being a civil engineer provides a lot of opportunities for you locally and internationally. As mentioned previously, many countries are showing a significant skills shortage in civil engineering. Therefore, there are many opportunities to live and work abroad. Some companies even require you to travel around, so you'll be seeing the world while you are getting paid well. As I've already explained, civil engineers are always in demand. And with the increase in environmental initiatives, rapid expansion, and development programs over the last few decades, the demand for those who can design, create, understand, and modernize the built environment has increased dramatically. And these initiatives are set to continue and, in fact, increase in the future. Therefore, civil engineering is one of the most in-demand professions in the world, with vacancies set to rise into the millions. Civil engineers are happy, just like every other engineer. They report a high degree of job satisfaction. So why do you think this is? In fact, it's due to a combination of factors: flexible schedules, travel opportunities, good benefits, job security, working as part of a team, and also possibly you may be involved in a project that produces something that will be around for hundreds, if not thousands of years. Again, think of the pyramids. Engineers, more specifically, civil engineers built them. Civil engineers make a difference. As previously mentioned, they address real world problems. They fix things that are broken and improve on existing, and they come up with new innovations, thus helping the world move towards a brighter future by solving problems with pollution, finding ways to harness new energy sources, and building new structures. But first and foremost for me, civil engineers help people. This may be giving people with disabilities the opportunity to live the best life they can, or giving people clean water to drink. They literally do it all. So studying civil engineering will provide you with a taste of all the various skills and knowledge required to work in any sub-discipline related to it. However, it, oh, if you know what route you would like to take within the main discipline, think about choosing to specialize early on and choose a degree that suits your desired path. Over the next few slides, I will introduce you to some, but certainly not all, of the sub-disciplines of civil engineering. Okay, the first being highway engineering. Highway engineering is a specialized field within the discipline of transport engineering, with highways being a major feature of any industrialized country, and moreover, their economies depend on them for transporting goods and enabling key workers to commute to work. Highway engineers consider all aspects related to the design of the roads themselves, as well as how pedestrians are managed. Highway engineers study traffic volumes and patterns to determine the best strategies to minimize traffic, prevent collisions, and also limit damage to the road structures caused by the passage of vehicles. Interestingly, there has been a rapid rise of integrated electronic and automated systems in recent years, and highway engineering has expanded to include a new area of focus for this discipline on the implementation and use of intelligent transport systems. In other words, smart motorways that will eventually revolutionize the way we travel day to day. Another area of interest has seen the use of IoT, or Internet of Things devices, to measure the health of bridges. For example, real-time tracking of traffic volumes and measuring vibration frequencies, amongst many, many others. The vibration frequencies, essentially, the more a bridge, for example, vibrates, the more maintenance is required on it. And that's what these IoT devices do. Okay, environmental engineering. Okay, this is huge at the moment, and this trend it will continue into the future, and quite rightly so. Environmental engineering is dedicated to the creation of strategies to protect and improve the environment, with the main focus being on maintaining water, air, and land quality, with a huge emphasis being placed on sustainable practice, methods and results. They create case studies and then create plans to prevent natural disasters such as flooding or drought and pollution. Most of their work is completed in an office with a big emphasis on data analysis and statistics. In that regard, they're using a lot of artificial intelligence systems, mainly machine learning, for statistical analysis and predicting future trends, i.e., for flooding or drought, and also pollution, as I've said. Unlike other civil engineering disciplines, environmental engineers rarely use design and simulation software, which we'll be using today, but instead rely on data, statistics, and ethics to guide them. Due to the complex environmental laws that govern their every move, graduates of this discipline tend to have a better understanding of ethics and social problems than other civil engineering disciplines. Environmental sorry, I can't get my words out. Environmental engineers are hugely in demand for government projects and by parks departments to implement strategies to deal with pollution, waste management, and noise levels, amongst many others. Some private companies also utilize the expertise of environmental engineers in their activities, if their activities have a potential adverse effect on the natural environment. Consultancy work is another possibility, with many research positions opening up across universities and private companies as they ramp up their efforts to combat climate change. And environmental engineers implement strategies to deal with these, or to combat these problems, essentially. Okay. Another area is structural engineering, which was my area of focus for many, many years. Structural engineering focuses on the design of structures that are required to withstand loads, such as bridges, and environmental elements, such as skyscrapers, and how they react to wind. These structures can be categorized into houses, buildings, bridges, and even monuments. All of these structures are composed of a number of components arranged to use the fewest amounts of materials possible to produce the most stable construction. Collaboration with architects is an essential on most projects as a structural engineer is involved in. Architects provide the external design and aesthetic appeal, while the structural engineers design the internal skeleton and foundations to ensure the building functions correctly and, more importantly, does not collapse. Another interesting field for structural engineers is it's not just the designing of buildings, they also look after the maintaining of buildings, or if, for example, a building is subsiding. An ideal example of that is the Leaning Tower of Pisa. Okay, it's leaning because it's actually subsiding or sinking. Okay, so structural engineers, which was my area, they essentially stop a building from falling over if it's sinking, and also shore up the building after you've actually stabilized the foundations, if you like. Structural engineers prepared the drawings and specifications of the structural elements. They have exceptional understanding of materials and their properties, allowing them to select the best ones for every situation. Graduates of this discipline possess fundamental design skills, which we will be using today, in-depth knowledge of building codes and regulations, with most opportunities being in the commercial and industrial sectors. Okay, so in conclusion, choosing to study civil engineering or any engineering discipline in that matter is, in my opinion, is and will continue to be the best decision you can make. You will enjoy a massively varied and fulfilling career with the knowledge that you're making a difference, however large or small. Okay, so thank you for taking the time to listen to me babble on about civil engineering, and I truly do hope it was interesting and informative. So now, on to the exciting bit, the interactive demo. Okay, so what will you be doing? You will get the opportunity to design a truss bridge. Okay, the reason I chose a truss bridge for us to design is essentially you will see them everywhere. They're the most common bridge you will see, essentially because they're so cheap to actually produce. You will be familiar with trusses because they're evident across everything from roofs to joists all the way to bridges. Essentially, a truss is an arrangement of straight members, or usually straight members that are usually forming triangles. And the reason they actually form triangles is essentially there's a massive trade-off when you're actually building any sort of structure between strength and weight. Okay, so trusses actually offer immense strength for very, very little weight. Okay, so that's why they're the most common. Okay, so to do this, we're going to use the platform called Tinkercad, which I'm sure some of you will be familiar with by now. Again, it will introduce you, the students, to the product development life cycle, which is design, simulate, and prototype. Obviously, we're not going to be able to prototype this bridge, but if you do have access to a 3D printer, please prototype this yourself. It basically, with the designs in Tinkercad, you're able to actually export the design, and it is 3D printable. Okay. Another interesting fact about Tinkercad, it's an ultra simplified version of software that you will be using daily during your academic and professional careers. Okay, so in the design stage, you will have the opportunity with me guiding you to design the truss bridge in 3D. And right, okay, so is everybody ready? Have you all signed into Tinkercad? Can you have a show of hands, everyone who signed into Tinkercad?
Carl, can you send the link again so they can open if in case they don't have it saved from last class?
Yeah, no problem at all. Just give me 1 second.
So, galerinha, já está sendo enviado para você o tutorial step by step por e-mail, tá? Então vocês vão receber. O professor Carl vai colocar o link do Think Card, card here no chat.
Just 1 second, I shall get that over to you. Okay.
So, Professor, I just said to Dan the PDF has already been sent to Dan, and I'm very excited for this class because I'm a civil engineer. So.
Oh, excellent! Hey, well, there you go. Brilliant. There we go. Okay. Well, you'll be familiar, really familiar with trusses then. Really familiar with them. What I will say, let me just get rid of this screen. Okay. What I will say to you all is, this is not an easy tutorial. Okay. It's really, really, really fiddly. Okay. So do not worry if you do not follow along. Okay. That PDF is there for if you do fall behind. Sorry. You will be able to pick it up later on. Okay. So again, it's not an easy one. This. All right. You will see that in a minute. Okay. Right. Okay. Let me just open this PDF up. Okay. As soon as you have all signed in to Tinkercad, could you all just raise your hands and just let me know when you've signed in, and I will carry on, if you don't mind. Okay. So what did you specialize in, Diego? In civil engineering? Did you specialize in any subject or?
No, any subject, Professor. I finished the civil engineering and then I went straight away to Australia. So.
Oh, nice. Very nice. Well, there you go. There's the global opportunities for you. Okay.
There you go.
Yeah, you can basically go anywhere with civil engineering.
I know.
There's massive projects going on in Dubai, or sorry, there has been going on in Dubai. For example, reclaiming land from the sea. If you have a look online and have a look for the palm tree, it's
amazing. It's amazing.
It is. An interesting fact about that, though, where the palm leaves are, essentially, it's trapping the water in there, so the water's getting stagnant, and it absolutely stinks.
Really?
Water. Yes. So they're actually having to implement things now to pump clean water into it. Yeah, so it's stop it from smelling. Yeah.
Oh, wow. I didn't notice when I was there. I was like, I was just fascinated to everything, but I didn't notice the smell.
Yeah. So it's been a massive issue that they've had. They may have actually corrected it by now, but yeah, that's been a massive issue that they've had. The water going stagnant.
But is the only palm tree or on another construction there, which you got the water tracked?
Well, that was it on the palm tree. So that's something I was told by one of my friends. He's actually doing or just completing his masters in civil engineering now with Liverpool John Moores, which is my local university, and that was one of his lecturers told him that it absolutely stinks. Yeah.
Wow.
Yes. Okay. So right. Okay. We've got a couple of hands so far. So when did you go to Dubai?
When I was coming back to Brazil, was in January last year.
January last year, was it? Right.
Yeah.
Okay. So they may have actually fixed it by then, but it's a place I need to go. I need to go there just to have a look at it. I'm a bit of a nerd if you're for engineering, and I love it. I love seeing anything like that. So
I'm a nerd as well. I was like fascinated with all the building and all the massive building that we got there. I was like, oh my lord.
Yes, it's absolutely fantastic what they've done in such a short amount of time. I know if any of that was going on in Britain, it would take us about 50 years to complete what they've done in like 10 years. So yeah, it's really fascinating.
Yeah, imagine the hospital in China, which got like 15 days to be ready. It was like, oh my gosh.
That's it.
Those Chinese.
Yeah, they plow into it, don't they? But again, it's the UK isn't like that. The UK is we're quite slow.
I'm not gonna talk about Brazil, so we can go.
Right, okay. How are we getting on? Is everyone okay? Have you all signed in? Show of hands, please. We've got a couple.
Galerinha, tem como vocês levantarem a mão? O professor Kroll tá pedindo aí para vocês levantarem a mão se vocês já conseguiram logar no Thinkercard.
There we go. Excellent. Okay, so while you were all finishing signing up, okay, the first thing that any civil engineer does when it comes to a project, or when they before they even start planning the project, is they have a site survey. Okay, so this is where an architect and the civil engineer gathers the information about the place where the structure will be built. For example, obviously the size of the actual the size of the site that they're working with, the ground qualities. So they'll do boreholes where they'll determine the quality of the ground underneath, amongst many other things. Okay, so if you have a look at my screen now, hopefully you'll be able to see our site where we're actually going to be building the bridge. Okay, and our site is essentially we're going to be spanning a river. I know it says the sea on the PDF, but that should be changed to river. I will do that. The span will be 30 meters, which will be 300 millimeters in our design. 30 meters for a bridge is very short, to be honest. The bridge will be suspended over a river, not the sea, by 3 meters, sorry, which will be 30 mil in our design. The height of the bridge will be 6 meters, which will be 60 millimeters in our design. And the width of the bridge will be 4 meters, which will be 40 mil in our design. Okay, so it looks like everybody's ready to go. So let me move this out the way. Okay, I'll just drop that there. And I'll expand this. Okay. Right, so let me just open this up. Sorry about this, 1 second. Come on. Okay, are we having some issues with the, I think we're having a couple of issues with signing in. Okay, I'll give it a couple more minutes to sign in. And again, can you just raise your hands when you've done that, please? I think we had the same issues last week. It can be a little bit slow to actually start up. There we go.
Galera, tá todo mundo conseguindo?
If you could just keep an eye on that for me, Diego, and just let me know when to move on, if you don't mind. Please.
Yeah, that's okay. I have many students here saying that yes, is everything good to them?
Right. Okay. So there. So shall we move on? Shall we keep going or?
Galerinha, podemos seguir? Yes, Professor.
Let's do it. Okay. So once you're signed in to Tinkercad, you will be faced with the 3D Designs dashboard, if you like. Okay. So once you're at this stage, if you just click Create New Design, and it will work eventually. As I say, Tinkercad, it's not without its issues, okay? So it can be a little bit slow. Basically because of the amount of work it actually does. Okay, so once you've clicked create new design, you will be faced with the work plane or the workspace, 3D design workspace. Okay, so while we're at this stage and you're just getting up to that, I'll just demonstrate how you actually navigate this workspace. Okay, to zoom in and out, if you're using a mouse, you can zoom in by using the scroll wheel on the mouse. So move the scroll wheel forward to zoom in and backwards to zoom out. If you're using a laptop trackpad, use your 2-finger gesture on the trackpad. So open your fingers to zoom in and close your fingers to zoom out. Okay. To move around the workspace, if you right click and hold, and then just move the mouse any which way you'd like, and that will move you around the workspace. Again, if you're using the if you're using a laptop trackpad, just right click on the trackpad, and again hold and just move around the trackpad to move the work plane around. Okay. Another way which I will actually be asking you to do is something called snap. Okay. So if I ask you to snap front, okay, you will see a little square or a little cube in the left hand corner, top right hand corner. Okay. If I say snap front, just click on the front and it will snap to the front. If I say snap top, just use the arrows on the side of the cube and that will snap you to the left, right, top and bottom. Okay. So we'll start from the top, just like that. Okay. Is everyone okay with that?
Professor, some students are asking for a code.
Okay. Right. Let me just log out. And what you've tried to do, you've tried to actually access a class. We've not actually created a class in this, essentially because I'd need to email everyone the class number. So let me just log out and I'll show you where to sign in. Okay. Just 1 second, I will log in now.
Pessoal que não conseguiu ainda, só espera um pouquinho que ele vai mostrar para vocês como vocês têm que acessar, porque vocês não vão acessar como uma aula mesmo, porque senão ele tem que dar um código, tá bom? Ele vai mostrar agora para vocês. Yes, professor, when you're ready.
Okay, so when you were signing in, if you sign in, do not click students join your class. Essentially, as I've just explained, that's for if I actually create a class in this software. Okay, so the 3 links underneath, or the 3 blocks underneath, so you can sign in with any one of these. So me personally, I would just sign in with your Google accounts if you have them. Okay, if not, just create an account with AutoCAD themselves. So if you just click sign in or create an account with your Google account, and you basically use there we go. So you can basically just use your Gmail account to sign in with that. Okay, just let me know when you've done that and we'll carry on. With a show of hands, please.
Gabriel e Rodrigo, vocês estavam com um problema, vocês conseguiram?
Yes.
Great. Gabriel? Okay, professor.
Excellent, good stuff. Okay, so I'll start from the beginning again. Okay, so essentially, when you sign in, you will be faced with the 3D design dashboard. Just click create new design. And again, you'll be faced with the design workspace, if you like, 3D design workspace or work plane, if you'd like. Again, to navigate this work plane, essentially to zoom in using a mouse, scroll forward with your mouse wheel to zoom in, backwards to zoom out, to traverse around or to travel around the work plane itself. Right click on your mouse, right click and hold, and then move the mouse around to navigate around the work plane, just like that. You can actually do this using your mouse the trackpad on your laptop also. So to zoom in, just open your fingers. To zoom out, and close your fingers. Okay. Another way of navigating the workspace, you will see a cube in the. I've lost my mouse cursor. There he is. You will see a cube in the top left-hand corner. Okay. So if I say snap front, just click the front of that cube and you will snap to the front of the design. If you ever say snap top, just click the triangle at the top or click on top and that will snap you to the top. And the same for all the others, left, right, and bottom. Okay, right. So the first thing that we're going to do, we're going to set the scene. Okay, so what I would like you to do is create down in the bottom right-hand corner of the work plane or design workspace, click edit grid. And then I would like you to change the width of the work plane to 400 millimeters. And I would also like you to change the length to 40 millimeters. Oh, just like that. And then just click Update Grid. And you should be faced with the design or the work plane just like what's on my screen now. Okay. Another thing I would like you to do is you'll see just underneath Edit Grid. I would like you to change, it's called Snap Grid. I would like you to change that to 0.1 millimeters, please. There you go, just like that. Okay. I keep losing my work. There we go. Okay. And again, can I have a show of hands for everyone who's completed that, please?
Can you repeat, please?
Yeah, sure. 1 second, 1 second. Let me just, I've lost my PDF now. There we go. Okay. Right. Okay. So the first thing I would like you to do is edit the grid. Okay. So basically what you're doing here, you're changing the dimensions of the actual work plane itself. Okay. So if you click Edit Grid on the bottom right-hand corner, okay, the grid properties screen or grid properties block will appear. And then I would like you to change the width of the work plane to 400 mil. And then the length to 40 millimeters. And then just click Update Grid, just like that. And then when you've completed that, you will see another button just under, or a drop-up box, or a rise-up box if you want, called Snap Grid. And I would like you to change that to 0.1 millimeters. Please. And then let me just open that back up again. Okay. Again, can I have a show of hands if everyone's completed that, please?
Todo mundo conseguiu? Todo mundo conseguiu? Mateu? Sorry, Professor.
Okay, no, it's no problem at all. No problem at all. Again, it's we'll take this nice and slow because it's really, really tricky. Okay, just to get it. It's you will see. Okay, I won't explain it now because you may not understand, but you will see.
Yes, Professor, I have some yes here, so I think you can go forward.
Let's do it. Okay, so the first thing that we're going to do, we're going to set the scene. Okay, so we're going to add the banks of the river. Okay, so on the right hand side, you will notice that when we're actually building something using Tinkercad, all that we use is basically basic shapes. Okay, so boxes, cylinders, spheres, and prisms, and so on and so forth. Okay, this is the same as another piece of software brought by AutoCAD called our AutoCAD Inventor. Okay, and essentially with Inventor, you can actually just build things out of shapes. Okay, right. So you will see in the shape or the component search bar on the right hand side, you will see the box, the red box. Okay, if you just click on that and drag one over to the left hand side of your work plane, okay, and you will see, I'll zoom in for you. Okay, let me just spin that around so you can see it. Okay, let me zoom out so you can see it. Okay, you will see when you create that block, white squares all the way around it. Okay, with these white squares, you're able just to click on the white square and then change the dimensions or change the sizes of the block. Okay, so the first thing that we're going to do, we're going to change the height of the block. Okay, so the height of the block is going to be 30 millimeters. So if you click at the top white box, you will change that to 30 millimeters. And this is because the bridge is going to be suspended 3 meters above the river. Okay. The next thing that you're going to do, you're going to change the width of the block. Okay. So the width of the block is going to be 40 millimeters. Just like that. And then the length of the block is going to be 50 millimeters. Just like that. Okay. Once you've actually done that, if you just move around the work plane and just make sure that the box is actually on the work plane, because if you don't create it just like that, and you look at it, if you're looking from that orientation, it looks like the box is actually on the work plane. But if you look from underneath, you can see that it's not. Okay. Can I have a show of hands when you've completed that step, please? Oh, also, if you click on that box, we're going to change the color of that to green. Okay, essentially because it's the bank of the river. Okay.
Galera, se vocês estão acompanhando aí, levantem as mãos ou cliquem em reactions ali embaixo e põem ali a palminha ou o dedinho levantado. E se tiver algum problema, liga o microfone e pergunte pro professor ou manda uma mensagem no chat ali que vocês não se sentirem confortáveis. Mas vamos interagir aí com o professor, vamos aproveitar essa oportunidade.
Okay.
Professor, I don't know, I can't see the raise hands here in my Zoom, so I just asked them to go to reactions and then just put the thumbs up.
Yeah,
I
no
think
problem.
the
Yeah.
same thing, isn't it?
Yeah, if you click on the attendees or the participants.
Yeah, I can see the hands. They're raising their hands. Yeah, you can see the blue hands.
Found it.
Excuse me, Professor, can you tell me what are the measures of the cube, please?
Yeah, sure. Okay, I'll click on this. So if you look at my screen now, you will see the top square, top white square. Okay, if you click on that, change that in the little white box that appears to 30 millimeters. Okay, so your height is 30 millimeters. Your length is then 50 millimeters. And then the width is 40 millimeters.
All right, thank you very much.
No problem at all.
Galerinha, então vamos lá. Ó, quem tá tudo ok, entra lá nos participantes, aí tem um botãozinho escrito levante a mão ou raise your hand. Clica ali, por favor, para o professor ver que tá todo mundo bem, tá? E depois que ele falar ok, aí vocês colocam lower hand, que é abaixar a mão. Por favor.
Okay. So we've got a few hands. Okay, Sam, should I continue? Am I okay to continue?
Yeah.
Again, this is really, it can be quite tricky, this. So just take your time. Take your time. Don't rush.
Is this from Autodesk, Professor?
Sorry?
Is this from Autodesk?
Well, yeah, AutoCAD, Autodesk, yes, it is.
Yeah.
Yeah. It's you will be familiar with this.
Yes.
Yeah, you will be very familiar with this. I think the one I'm more familiar with essentially is just the 2D designs, and then we can extrude them to make it 3D. So it took me a little bit to actually because it can be really fiddly. So it took me a while to actually get used to the 3D software again.
Well, I don't know how to use the ArchiCAD. It's so annoying. I prefer Revit.
Right. Okay. Yes. Yes. Yeah. That's the problem with this software. Well, the software brought by Autodesk. It can be quite fiddly, really fiddly. But it's really handy for example, simulating you can't actually simulate in this software, but you can using Inventor and that sort of thing. So you can actually pull out hotspots, they call them. So areas where they're essentially going to be there's going to be the majority of damage. So really good bit of kit, actually.
Yeah, it's a challenge. Professor, can you just repeat the step to change the block color, please?
Yeah, of course. So if you just click on the block itself, just in the right-hand corner, the shape options will be displayed. So if I just click off that block again, I'll click on the block, and then just click on the solid where it says solid, and then just change the color to green.
Galerinha, ainda tem muita gente com a mão abaixada. Vocês estão acompanhando? Tá tudo certo? Podemos seguir?
Oh, yes.
Thank
You
you.
okay?
Yep.
Excellent. Yeah, brilliant. I'll be showing you a little bit of a trick now. When you're using software like this, you don't have to keep creating the same thing. Okay. You can use something called duplicate. So essentially, it just copies it and then you just drag it to wherever you need it. Okay. So I'll show you that now. This will become evidence why it's useful when we actually start creating the trusses for the bridge.
I think we can go, Professor.
Let's do it.
Yeah.
Let's go. Okay, so the next step you're going to do, you've created the left-hand bank of the river. So now what we're going to do, we're just going to create the right-hand side. So if you snap top, just like that, and then click on the block itself, the block you've already created or the bank you created. And then just on the top right-hand corner, let me just try and straighten this block up a bit. Okay, so if you click on the block, in the top right-hand corner next to the garbage bin or the dustbin, whatever you want to call it, right next door to that is a button called duplicate and repeat. Okay, so if we click that, that actually creates a duplicate of that block inside the previous block. So if we just right-click and hold, and then just drag the duplicated block to the opposite end of the work plane, just like that. Okay, and then again move around to make sure that the block is actually at the end of the work plane, just like that. Okay.
Sorry, Professor. Pedro, você perguntou alguma coisa? Pedro Henrique, você abriu o microfone.
No, I'm only pressing if Professor can repeat the process.
Pedro, desculpa, tá cortando muito. Você pode digitar? Sorry, Professor, he's going to type. I think he's...
Right, okay. He's experienced a little bit of echo on his microphone. And what you will all notice while we're waiting, you will all notice that essentially we're just going to build this whole bridge out of one shape, okay? And that's how easy, well, I say that's how easy it is. It's really not easy, okay? But it simplifies it. Essentially, if you're using the software that I've used in the past, you would actually have to create each of these blocks just with lines. Okay, so you know, again, it makes it so much easier.
Professor.
Yeah.
Can you repeat the last step, please?
Yes, of course. Okay, so what I'll do, I'll delete that block. So this is another thing as well. Sorry, I should have mentioned this earlier. If you make a mistake or you just want to remove a block or you've duplicated something twice, if you just click on the block itself and then just click delete, it will remove the block. Okay. So the last step, if we've just created the left-hand bank, if we click on the left-hand block, just in the right top left-hand corner, you will see a dustbin or garbage bin, whatever you would like to call it. Right next door to that, on the left-hand side, you will see another button called duplicate and repeat. Okay, if you just click duplicate and repeat, that actually creates a block inside of the block you duplicated. Okay, so if you just left click and hold on that block, you'll then be able to drag a new block over to the other end or the opposite end of the work plane. And again, just swivel around the work plane itself to make sure the block is actually completely on the work plane. As you can see, mine isn't. So if you just click on it, left click and hold, You can then just move that block wherever you need to. Okay. And that is the problem that you were going to have all the way through this, is making sure the blocks are in the right place. Okay. To duplicate blocks, say for instance, you've made a square, okay, out of blocks. To duplicate that whole block, you've got to make that whole thing a block in itself. All right, and if the blocks aren't touching, it will not group the blocks. But we'll talk about that a little bit further later on. Okay, how are we all doing? Everyone okay?
Okay, Professor.
Brilliant, excellent. And this, it's really fiddly at the moment when you're just learning it, but believe me, I will show you at the end what other students have actually created with this. They never stopped with bridges. They've actually designed full cities or a little cityscape within it. So it's really, really good software. Okay. Again, just let me know when you would like to continue.
Galerinha, vamos levantar a mão se está todo mundo entendendo, está todo mundo no mesmo step. Lembrando que é só clicar ali em participantes e levantar a mão. Por favor, gente, isso ajuda muito aqui a gente acompanhar e para não atrasar muito a aula, por favor. E se tiver alguma dúvida, pode ligar o microfone e perguntar diretamente para o professor.
Okay, so we've got loads of hands now, loads of hands.
Yes, I think we can go.
Yeah, let's do it. Okay, so the next thing that we're going to do, okay, we're going to create a new work plane. And what I mean by this is where we've just built the actual riverbanks, okay? So the work plane for that is essentially the river, okay? So we need to create a new work plane on top of the banks of the river, essentially where we're going to build the bridge, okay? So again, in the component search bar, or the shape search bar, if you'd like, you will see just at the top of it where it actually says work plane. It may not say work plane. Well, obviously it will say work plane, but it'll be in there Portuguese, I think. Okay, I know we had them issues last time, right? So if we just click work plane, and then we move this over, you will see a white square, just following your mouse cursor. If you just drop that on top of the left-hand bank, and just click to drop it, as you can see, it just creates a new work plane on top of the bank. And this is where we're going to start to build the bridge, okay?
Galerinha aqui não... Sorry, professor. A galerinha que tá todo mundo usando aí o Chrome em português, se não me engano é área de trabalho. Todo mundo achou?
Plano de trabalho, plano de
Isso.
trabalho.
Boa, Gabriel. Mesma coisa, gente. Vamos levantar a mão aí se está todo mundo acompanhando, se deu tudo certo aí com o plano de trabalho. Sorry, Professor, when you're ready.
No, totally excellent. No problem at all. Again, just take your time. There's no rush. There's no rush. I would prefer it if you were all basically got to finish the bridge than rush, you know. So the next thing that we're going to do, if you just snap front. So when I say snap front again, just click on the cube in the top left-hand corner, and just click on front, or whatever it is in Portuguese. I don't speak Portuguese, unfortunately. Okay, so what we're going to do now, we're going to create a vertical strut. Sorry, no. 1 second. I have got the wrong. I've got the wrong PDF. So here we go. I've made a mistake there. There we go. Just 1 second. There we go. Okay, so now I'm using the right one. Okay. So the first thing that we're going to do, we're going to create something called a stringer, okay? And this is essentially just a horizontal bar, okay? It's going to start forming a part of the truss or a quarter of the truss, okay? So to do this, again, we're going to use our friend the block or the box, okay? So we click on that, and we're going to drag it over to our work plane, just there, okay? Just move it just away from the work plane, just like that. Okay, and then we're going to change the dimensions of this block again. So the height is going to be 1 millimeter. Okay, the width is going to be 1 millimeter, just like that, and its length is going to be 75 millimeters, just like that. Okay, so if I zoom in on that, so it should just look something along them lines. And we're going to leave that color as red, okay? We're going to pretend that the bridge is painted red. If you would like me to repeat them dimensions, okay? So we've got a height of 1 millimeter, a width of 1 millimeter, and a length, excuse me, of 75 millimeters. Okay. And again, just you let me know when you're ready to continue. Also, a little bit of an intro. If you have a look at the PDF, it actually it talks a little bit at the beginning about why trusses or truss bridges are so popular, and it actually moves into the realms of how they dissipate loads. And why they are so strong. So it's a little bit of an interesting read if you'd like to have a look at it. Well, I think it's an interesting read anyway.
Galera, o PDF já foi enviado para vocês, tá? Foi enviado para vocês faz um tempinho já. Se vocês não estão achando, dá uma olhada na caixa de spam, no junk box de vocês aí, mas foi enviado para cada um aí.
When you've created the block, just try and get it as close to the to where the banks are, so straight in the middle of the banks, but as close to the actual work plane as possible. But it doesn't need to be on top of the work plane at the minute.
Ô Dani, se você quiser abrir o microfone e perguntar, pode ficar à vontade, tá? Se quiser que eu pergunte aqui. Sorry, Professor, can you repeat the measure, please?
Yeah, sure. Okay, the height is 1 millimeter, the width is 1 millimeter, and the length is 75 millimeters. Okay. Are we all doing? You're all okay?
Yeah, we have loads of hands
Yeah,
here,
brilliant.
Professor.
Let's go. Okay. Right. Okay. So the next thing that you're going to do, we're going to add a new work plane again. So what we're going to be doing, this is the beginning of the truss. Okay. So this is essentially 1/4. Or 1/8, if you want to look at it, because you've got two sides. 1/8 of the bridge we're going to create now. So if you, again, click on work plane, which is at the top of the component search bar, and we're going to create a new work plane on top of the stringer we've just created, just like that. Okay. Right. And once we've done that, what we're going to do, we're going to build now a vertical strut. Okay. So to do that, if we just click on the box, our friend the block box again, and we move that box just on top of the stringer we've just created. Okay. And I've lost my PDF again. Let me just, what we're going to do now, we're going to change the dimensions of this again, and we're going to change its length to 1 millimeter, its width to 1 millimeter, and its height is going to be, so the height of the bridge is 6 meters. So we're going to change this to 60. Right, sorry, 6 meters. So we're going to change that to 60 millimeters. Okay. And once you've actually done that, again, move around your workspace. So let me just get rid of that. Move around your workspace just to make sure that the two parts are touching. As you can see with mine, they're not. Okay. So click and just move it over to the end of the stringer we created. And again, just look from all angles just to make sure. This is the very, very tricky part, because you can look at it from one angle and it'll be okay, and you'll look at it from the next and it will be nowhere near it. There we go. There we go. Just like that. Okay. And you should be left with something along them lines. So what's going on my screen?
Professor,
Yes.
can you repeat, please, the last step?
Yes, of course I can. Yes. Okay. So what I'll do, I'll
Thank you.
just, yeah, no problem at all. I'll just get rid of that one. So what we're going to do, we've created, well, yeah, let me just, I'll move that back and then I'll start from that side. Okay. So what we're going to do, we're going to create a new work plane on top of the horizontal stringer, if you'd like. Okay. So if we click on work plane, which is on the top right hand of the component search bar, excuse me. So if we click on that, and then we're going to create a new work plane just on top of that, on top of that stringer, just like that. So you should be faced with something along them lines. Okay, if you look at my screen. Then what we're going to do, we're going to create the vertical strut for that. So again, using our friend the box on the right hand side, if we just click on the box and then we drag that just on top of the stringer we've just created. Okay, we're then going to change the height of the vertical strut. We're going to change the height to 60 millimeters. Okay, we're then going to change the width to 1 millimeter, and then the length to 1 millimeter also, just like that. And once we've done that, if we just move around the work plane, as you can see, if I look at it from the front, it looks like it's actually connected, but it's not. So if we move around the work plane just like that, you will see that they are miles apart. So if we zoom in slightly and keep moving around so you can actually see it. And then what we'll do, we just click on that block, left click and hold, and then we can drag that block just onto the stringer, just like that. And again, just move around the work plane just to make sure that it's touching all the way around. Okay, just like that. Okay. Again, show of hands when we're okay with that.
Thank you,
Or
thank you.
no problem at all. Or if you don't want to show your hands, just say yes. It's no big deal. Okay, whatever you want. So we've got a few hands up so now.
Galerinha, se lembra que vocês podem ligar o microfone aí e falar yes pro professor, tá? Pra gente não ir com a aula aí, tá bom?
Yes, Professor.
Are you okay? Yeah. Okay. Right. Again, this isn't easy. It's not an easy. It's not an easy thing to do. Okay. It does take time to get used to it, to get used to the software and how to move the blocks around and that sort of thing. So don't worry. Don't panic. All right. You will have that. You have that PDF now. Sorry. So if you do fall behind slightly, don't worry about it. You can actually complete it just using that PDF. Okay. So I think. Let me just have a quick look. Yeah, I think we've got plenty of hands there. Okay, so we'll move on. Right. So the next thing that we're going to do, we're just going to duplicate the block that we've just created now to form the vertical strut for the right hand side. Okay. So again, if we just click on that block, okay, we'll click duplicate again, which is at the top left hand side, sorry, of the screen next to the trash can or rubbish bin, whatever you call it. You just click on duplicate, click on the block and drag it over to the opposite side, just like that. And again, just move around the work plane just to make sure that it's actually touching and it's right on the edge. Again, just zoom in. And I can't believe it, I got it right first time. Oh no, I didn't. Just like that. Okay. And again, just to show our hands when you've completed that step, please. Oh, did I drop the hands on the last one? Right, so move the yellow work plane. Okay, so when you're creating a new work plane, okay, on the component search bar on the right hand side, you will see just a work plane button next to the ruler. Okay, if you click on that work plane, just like that, okay, you'll see like a little white box or a little blue box. Okay, to create the work plane, you just basically move that box over on top of where you're going to be building. So if I just click on top of that now, the work plane will be created. Okay, again, to create a work plane, if we just click on the work plane and I'll move it on top of the vertical struts. You don't need to do this. I'm just going to demonstrate how to do it. So you just go over on top of it, move that box on top of it and click just like that. And that will create the work plane. Okay. So I'm going to move that back down here because that's where we're going to be working. Okay. Okay. Is everyone okay with that?
Sorry, Professor, I think we just got a doubt here. How do you move the yellow work plane?
Yes, that's no problem. So essentially, all we have to do is click on work plane on the right-hand side or the work plane tool. Okay, so we just click on that, and then you will see when you move your mouse cursor, there's like a little box with a cone inside of it. So if you move that, just so it's on top of where we're going to be building things. So for this example, it's going to be on top of the stringer, okay, or the horizontal bar, Okay, so if you do that and you just click when the box is on top of that the stringer, it will create the work plane. Okay, and that's how you move that around.
Thank you, Professor.
No problem at all. Okay. Again, you just
Galerinha, conseguiu? Desculpa. Conseguiu, gente? Vamos falar yes no microfone ou levantar a mão, por favor.
Yes.
excellent. Good. Okay, so let's move on. Okay, so the next thing that we're going to do, we're going to duplicate the horizontal stringer. Okay, and we're going to move that so it's at the top of this eighth of the bridge. Okay, a little bit complicated, but what we're going to do, okay, if we just move that work plane, so we click on the work plane again, if we move the work plane just on top of the bank block on the left hand side again, so we just click there and then we've created the work plane on that block. Okay, the next thing we're going to do, we're going to use our friend duplicate again. Okay, so if we click on the horizontal stringer at the bottom, click duplicate on the top left hand side again, just by the trash can or the rubbish bin, whatever you call it. Click on that and you'll see, once you created the block or you've highlighted the block, you will see a black triangle above a curved arrow. Okay, just click on that, left click and hold, and just move that up to the top of the vertical struts and just release. Okay, and just like that. And again, just move around your work plane just to make sure that each one of them blocks are touching. Okay, this is probably the most complicated part of it. Okay, I guarantee you after this bit we'll fly. Okay, where it'll just flow from here, because essentially all we're going to be doing from here is using our friend duplicate. Okay, again, just say yes when you've all completed that. Or if you've got any issues, any questions, just let me know. You can't move the yellow work plane. Okay, so to move the yellow work plane, okay, again, on the top right-hand corner of the component search bar, you will see work plane. All you do is just click on that work plane like that. And then once you've clicked on it, you will see when you move your mouse cursor, just like a little blue box with a triangle in the middle of it. Okay. To move the work plane, all you do is just basically put that box where you're going to be working or on top of what you're going to be working, and then just left click to drop it, and that moves the work plane or changes the work plane.
Galerinha, vocês estão conseguindo?
Oh, yes.
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 Brilliant. Okay, so I'll just repeat that step. So I'll move the work plane back to away from it. So what we need to do now, we need to create a work plane just on top of the horizontal stringer again, because we're going to be building on top of that. So if we go to the work plane tool on the right hand side of the in the component search bar, Okay, so just at the top, we click on that, and then we'll move that work plane just on top of the horizontal stringer at the bottom, just like that. Okay, and then what we're going to do, we're going to now create the diagonal, a diagonal member, okay, which will basically go from corner to corner. Okay, so to create that, what we need to do, we first need to use our friend in the box again. Okay, so if we click on that, we move it over to the work plane. You can just move it away from the actual work piece for now. We're going to change the height of this to 50 millimeters. Okay, then we're going to change the length to 1 millimeter and the width to 1 millimeter, just like that. Okay, once you've actually completed that, okay, you've changed the orientation and all and everything like that. What we're now going to do, sorry, we're going to tilt this member on a 45-degree angle. Okay, to do that, just when you've highlighted the new block, you'll see just above it, you've got the curved arrows and the triangle. If you just move your cursor just over them curved arrows, you will a compass, if you like, or a protractor, more like, will appear on the screen. Okay, so we just click on that, and then just click on the box just above it, which says 0 degrees. If we just type into there minus 45, oh, it's gone. If we click minus 45, which is basically minus 45 degrees, which will tilt it to the right, just like that. Okay. And then what we're going to do, if we click on that box again, the block we've just created, we're now going to change the dimensions of the block again. Okay. And we're going to change the dimensions to 75 in length. So the white box just at the bottom, we're going to change that to 75. Okay. And the height, we're going to change to 60. Just like that. And you will notice when you actually move it onto the work plane, it's too high now because we've tilted it. Okay, so to drop it down, that's black triangle just above the curved arrows again. If we just click and hold on that, left click and hold, and we just drop it down so it meets the bottom corner of this the square. Okay, and again, zoom in just to make sure that it's touching all the way around. Just like that. And again, if we look at the top, just make sure it's all touching all the way around. Okay. Let me just zoom into that a little bit more so we can see it. Okay. Right, I promise you, this is the hardest part, okay? I promise. Just getting this bit right is the hardest part. Again, just you just let me know when you're ready to continue.
Galerinha, quem conseguiu aí, levanta a mão ou fala alguma coisa no microfone. E quem não conseguiu, tiver alguma dúvida também, pode perguntar, tá bom? Sorry, Professor. Can you just tell us the measures again, please?
Yeah, sure. Okay, so when you first create the box, it's going to be a straight vertical strut. Okay, so once you create that block, let me find the dimensions. Change the dimensions to a height of 50 millimeters, a width of 1 millimeter, and a length of 1 millimeter. Okay, once you tilt it on tilt it to the right. Okay, so I'll repeat the step on how to actually tilt it. Okay, so if we click on the block just like that, you'll see a curved arrow at the top just like that. If you just click on that, and then in the box at the top, which indicates what angle it's on, if you just type into there minus 45 degrees or minus 45, okay, excuse me. Once that is completed, you will see the dimensions have changed slightly, okay? So the height of that, once it's been tilted, needs to be 60 millimeters, and the length needs to be 75 millimeters. Okay, and then just move it over into the center of the square we've just created. Okay, and again, just move around the work plane, or the workspace, I should say, and just make sure it's touching in all corners. Okay, it's very, very important that it's touching everywhere. Okay, you'll see this. You'll see why in a moment. Again, this is not easy, okay? This is not an easy tutorial, this. It will take you time to get there.
Galerinha, quem conseguiu aí, fala alguma coisa. Fala I got it ou levanta a mão. E quem não conseguiu, manda as perguntas aqui que o professor ajuda.
I got it.
You got it? Good, good, good. Well done, well done. It's not easy. It really isn't easy, honestly. You know, so don't worry about it. Again, if you're struggling a little bit, you've got loads of time to do it yourselves. Loads and loads of time. And again, expand on this. Don't stop with the bridge. Build a city. And I would like, if you do build something like that, please send it to me. I'd love to see it. Okay. Right. Okay. So I think we're okay to carry on now. Right. So what we're going to do now, we're going to make, this is 1/8 of the whole bridge. Okay. So what we're going to do now, we're going to make this whole, what we've just created, we're just going to make this one block. Okay. So to do that, if you just off the actual workpiece itself, or that square we just created, just off that, if we left click and hold, and just drag a box around the square we just created, okay? Make sure you don't pick any other box up, say for instance the banks up when you're doing this, okay? So we've highlighted that now, which highlights the whole thing, okay? And just above, you will see like a shapes box be created. Just in the top right, or just above that, you will see a button next to a light bulb called group, okay? If you just click group, that's going to group all of them pieces together, okay? So that now, as you can see, I'm moving it around, is just one piece in itself, okay? And then after that, all we're going to do is we're going to use our friend duplicate again. So if we click and highlight what we just grouped together, click duplicate, which is at the top left hand corner, just next door to the trash can or rubbish bin again. If you just click on that, and then we're going to drag another 1/8 of the bridge just next to it there, like that. Just pull it forward slightly, because we're going to actually have to perform some sort of action on this now to make it the opposite way round. Okay. Again, just tell me when you're ready to continue. Yes, you're right. It's not. It really isn't easy. I am challenging you here.
But they're doing great.
Oh, yes, they're doing really well. Really well. I'll be honest with you, because I haven't used 3D design software for a very, very long time. Okay, it took me a day or so just to refamiliarize myself with this software. So I understand that it really isn't easy. Okay, so there's no rush. Okay, no rush whatsoever.
Sorry, Professor. Gabriel Botcher, he said he couldn't complete the last step.
Okay, which the last step where we duplicated or grouped the box, which step was it?
Gabriel, você pode falar qual step que você não conseguiu? Mas tem que ser um pouquinho mais específico, Biel, senão a gente não consegue saber.
Right, okay. I think this will be where we created the diagonal brace. Is that okay? Yes.
Yeah.
Yeah, okay. So what we're going to, what I'll do, I'll ungroup that. Okay, I'll ungroup that. Just 1 second. Oh. As you can see, if you do get any of the block in there, we'll just create it. So I'll just ungroup this now. Okay. So, and I'll remove that. Okay. So to create the diagonal, okay, again, the work plane must be on top of the horizontal stringer. So again, work plane is just at the top right-hand side of the component search box. If we click on that, we create a new work plane on top. Right. I'm going to answer that question now. Oh, I've made that mistake. I've made a mistake there. Okay, so we're going to create the work plane, but we're going to actually put it on top of the vertical stringer, just like that. Okay. Sorry, the horizontal stringer, just like that. Okay, and to create the actual diagonal block, if we just click on the box, which is on the right-hand side, drag that over on top of the horizontal stringer. We'll change the height to 50 millimeters, just like that. The length is going to be 1 millimeter, and the width 1 millimeter, just like that. Okay, and then I'm going to move that towards me slightly. Okay, then what we're going to do, we're going to tilt this diagonal member on a 45-degree angle. Okay, so if you see the curved arrow just above the actual block itself, if we click on that and we change that to minus 45 degrees, which will tilt it to the right, just like that. And again, what we're going to do, we're then going to move that diagonal block just over to the square we created. And again, we're going to drop that down so it meets the horizontal stringer. So to drop it down, you will see a black triangle above them curved arrows. If we just left click on that and just drop it down so it meets the bottom of the square we created. And again, just zoom in to make sure the diagonal block is right on our workpiece, just like that. Right. And then we'll move it across again just to make sure that it's actually there. Just like that. Okay. And once we've got to that point, okay, if we change the length of this to 75 millimeters, just like that, and then the height we're going to change to 60 millimeters. Okay, just like that. And again, just make sure it's touching all the way around. That needs to be rose up just ever so slightly. Just like that. Just like that. And again, just move around the work plane just to make sure that it's actually in the position that you would like it. I mean, don't be too careful about it, okay? If it's, as long as it's touching, just don't be too careful about it. Because if you don't like me, I've got to make it perfect. It's just one of them things. That's what happens when you become an engineer. You become a little bit OCD about these things.
About everything, actually.
About everything, yeah. It's like, once you've actually completed that, once you put the diagonal stringer in, again, if you just draw a box or drag a box just around it, so to drag a box, move yourself away from the workpiece, left click and hold, and then just drag it around the workpiece that we've just created, and then we just click group. For some reason it's saying it's already grouped when it's not. Oh yeah, it is. There we go. And then we group that, and then we're going to duplicate that group, and we're going to create, just drag it to the side and we'll create this one. Okay. And I'm going to adjust that problem now. Would it be stronger if we did the other diagonal stringer, but on the other side? Yes, it would. Okay. Because if you remember from the very beginning, a truss is an arrangement of triangles. Okay. And the reason we use triangles is because triangles are immensely strong. And that's just because of the way they dissipate the load. Okay. So that could be either compressive loads or tensile loads. Compressive, push together, tensile, pulling apart. Okay. So is everyone okay up to this point now? Are we all okay?
Okay, teacher.
Excellent.
I guess yes.
Okay. Again, don't worry about it if you're not following along too much. I've included the PDF. Just please follow the PDF. You will get it. You will get it right in the end, I should say. Okay. So what we're going to do now, if you just move your work plane, just so you can see the end of the part we've just duplicated. Okay. Again, you will see curved arrows just on the top. If we click on them, and if we just type into the top, into the box at the top, 180, just like that. So what's this going to do? This is going to flip the piece that we've just created 180 degrees. So it's going to turn it on its end 180 degrees. And we just click enter. And as you can see, it flips that workpiece. So it forms a triangle now. Okay. And then what we've got to do when we finish that bit, we'll move that piece just to meet the other one, just like that. And again, if we just move around the work plane, let's just remove that. If we move around the work plane, just to make sure that it's touching all the way around, just like that, and we're okay. Right? Okay. The next thing that we're going to do, after we've moved that into position, we're going to, again, draw a box or drag a box around the pieces you've just created, okay? And then we'll group them. So we're going to make them one piece in themselves, okay? Again, using the group button next to the light bulb on the top right-hand side. You click group. And then we're going to duplicate the block that they call it, that we've just created. We're going to duplicate that, again, using the button next to the trash can. And then we'll drag that to the side, just like that. And again, we're going to move it to meet. It's really, really difficult to... we're going to move it to meet the side we've already created, just like that. And again, just move around, make sure you're all in the right position, Make sure it's touching all the way around. And then we're going to repeat that step. And we're going to, so if you look at it from the back now, we're going to drag a box all the way around them two pieces. And we're going to group them together. Okay? And you've formed now one truss or one side of the bridge. Okay? Is everyone okay? Have we all completed that step? Are we all okay?
Okay.
Excellent. Okay.
The
So what
teacher,
yes?
could you repeat the measurements you used to make the last cube?
The last cube.
Yes.
Which member on the cube is it? Is it the diagonal member?
Yes.
Yes. Okay. So the diagonal member, once you've actually tilted it to minus 45 degrees, okay? What you need. So have you already created the block itself?
Yes.
Yeah. Have you tilted it to 45 degrees?
Mm-hmm.
Yes. Okay. So when you've tilted it to 45 degrees, change the length to 75 millimeters, and then the height to 60 millimeters, and then that will form your diagonal member. Then, okay.
Okay.
Excellent.
Thanks.
No problem at all. No problem at all. Okay. So as I've just said, we've now created one side of the truss. Okay. So how do you think we're now going to create the other side of the truss? How do you think we're going to do that? Shall we make it from the beginning, just like we've made this one? Or do you think there's an easier way of doing that?
Vamos lá, galera. Vamos responder aí. O que vocês acham que tem que fazer?
Any ideas? Right.
Cola.
What's that? Sorry, I missed that, man.
Well, I think we can just copy and cut.
That's exactly it. That's exactly it. Exactly it. So, as I said to you earlier on, forming that first square is the hardest part of it, okay? And this is using design software, okay? You're not supposed to create the same thing over and over and over again, okay? There's little tools that you can use within the software that just simplifies the whole thing, okay? So what we're going to do, first of all, we're going to move this whole piece over on top of the banks, okay? And again, if we just move around the work plane just to make sure that the bridge is actually sitting on top of the banks, okay? Because we can't have it hovering in the air because that wouldn't work, okay? And as you can see, this block's just slightly out the way. So we just move that in. Again, just make sure it's touching on all sides. Just move that bank just to meet it. Okay, just like that. Okay. So it's touching all the way around, just like that. Okay, what I'll do, I'll get rid of that work plane now because it's in the way. You don't need to do this. It's just so I can actually demonstrate it. Just like that. Okay. So now what we're going to do, we're going to duplicate this whole block. So we click on that, and then we click duplicate. And then what we're going to do, we're just going to drag the second half of the bridge just to the other side of the bank, just like that. Okay, and again, just make sure it's touching all the way around. This is massively important, that's touching all the way around, just to make sure that when we're actually grouping the blocks together, that it actually, it basically groups the blocks together. And also, if you do have access to 3D printers, I know I haven't at the minute, but a lot of people who do have access to these now, if it's not touching, you will not be able to print it, okay? So if you can let me know when you've completed that step, please, just by saying yes. And again, don't worry if you're not following along. You will be able to complete it just by following that PDF. And also, if you are going to follow on later on with the PDF, please, if you run into any issues, please let me know, okay? And I will help you with it. Okay? How's everybody doing? We're not far away now. I guarantee you we're not far away now. You've all done really well, to be honest. Again, this is not easy, all right? I thought I'd give you a challenge today, okay? So obviously, once you actually get this, once you get this done and get it working properly and you get used to the software, this is going to be a massive benefit to you when you start your academic and professional careers, because you're going to be ready and you're going to be used to the software you're going to be using, okay?
And also, this can be a great thing on their portfolio for application, right, Professor?
100%, 100%. If you do expand on this, you can actually have links. If you've got an online application, an electronic CV, resume, whatever you want to call it, you can actually put links to this, and it will link to your Tinkercad account. And it will actually show your designs as well. So it's really, really good. Really, really good. In your applications for work and also university as well. So really, really good. It's another thing. Do you have to create personal statements for university?
Not in Brazil, but they are. Yeah, but they are trying to apply for international university, and that's what Fiji does to help them. They can mention that, of course, right?
Yeah, that's it. So in a lot of universities, I know in the UK, ask for something called a personal statement. Okay, so that essentially just explains a little bit about yourself and about your experiences in life, and what software and what you've been studying in the past. This is ideal to be putting on your personal statements or your resume. Okay.
Amazing. So, para quem perdeu aí o webinar sobre personal statement e essay, é só vocês acessarem o canal da EFIGE e assistirem ali o webinar da professora Rebecca Stein, americana, falando como escrever um personal statement, como escrever uma essay. Galerinha, tá todo mundo conseguiu? Todo mundo tá certinho?
Yes.
Excellent. Okay, so we're running out of time a little bit. So what I'll do, I'll just carry on. This is like ultra simple side now. It's just basically creating straight boxes. Now, nothing complicated in this now. Well, not now. You know how to use it. Okay. So what we're going to do, we're going to create the work plane. Okay, but we're going to create a new work plane, but we're going to put it on top of the banks, just like that. Okay. And then what we're going to do, we're going to be putting in something called the floor, not the floor, the deck. I'll think of the word in a second. Floor beams, sorry, deck beams or floor beams. We're going to be calling these. Okay. So to add these, what we're going to do, we're going to be using our friend the box again. Okay. We'll click on that box and we're going to drag it over onto the bank just like that. Okay. And we're going to change the dimensions of these to 1 millimeter in height. Okay. 1 millimeter in length, just like that. Oh, sorry. No, it's not 1 millimeter in length. It's actually 40 millimeters in length. Okay. And then 1 millimeter in width, just like that. And then we'll change that block color to black. Okay. Just because it's a floor beam. All right. Once that's complete, once you've actually formed that block, we're going to then move that block just so it meets the edge, excuse me, just so it meets the edge of the two trusses, just like that. So if I zoom in, just like that. And again, just drag it back slightly so it's right on the very edge of the two trusses and it doesn't cross them, just like that. Okay. Again, don't worry about it. It doesn't need to be perfect. All right, so you can get that perfect when you're completing it on yourselves, on your own, I should say. Or if you need to complete it on your own. Right, okay. So that was a pretty simple step, that. And all we're going to do now, we're just going to duplicate this block 3 times, okay? So if we click on that block, we'll duplicate again. Okay, and then what we're going to do, we're going to drag this next block just to the opposite end And then we move around the work plane again, just like that. And then we're going to move that block just on the edge of these ones. The two trusses again, just like that. Okay, just make sure it's touching all the way around. And then the third and final floor beam, we're going to put at the center where the two triangles, the two triangles meet on each truss. So we duplicate that one, and then we just drag that one to the center, just like that. And again, just move around the work plane just to make sure it's actually in the right place. And it's touching all the way around. Okay. We've got one more block after this to create, and then that's the bridge finished. Okay. There we go. Obviously, a bridge would have more than 3 floor beams. Okay. So you can add them later on. Essentially, the floor beams would just meet at every one of these vertical struts. You would have a floor beam. Okay. But we're not going to do that because we're running out of time a little bit. All right. Okay. Is everyone okay with that? Just you let me know when you're ready to continue. And as you can see, it's now starting to resemble a bridge. It's now starting to look like a bridge. Okay, is anyone going to
Sorry, I have a question here. How do you call this bridge, this type of bridge?
It's called a truss bridge. Okay. So if you have a look at this side here, this is a truss in itself. And if you actually move into the world of civil engineering, right, you will see trusses everywhere. I mean, everywhere you'll see a truss. Essentially because, as I explained earlier on, there's a massive trade-off between strength and weight, okay? And the reason you see these everywhere in civil engineering or engineering in any form is because there's immense strength in a triangle or the arrangement of a triangle like this, and it's very, very light, okay? So that's why we use trusses. Okay, so some of you will actually see would already have seen trusses in roofs. In a roof, you will see roof trusses. Okay, again, to use them because they dissipate the loads really, really well. So, for instance, roof tile, that sort of thing, adds a lot of weight to a roof. You will also see them in the likes of floor beams like these. Or joists, we call them here. You will see them used in that arrangement now, essentially because they are so light and so strong. Okay, whereas in the past they used solid timber or solid I-beams, steel I-beams, which are hugely heavy, really heavy. So what they use now, they use composite trusses, which are part timber and part aluminium. Okay.
Thank you.
No problem.
Galera, todo mundo conseguiu aí? Podemos agora finalizar nossa ponte? Por favor, falem yes no microfone.
Oh, yes.
Okay.
Yes, of course.
Brilliant. Okay. So let's now, this is the last block before we've actually completed it. And what we're going to do now, we're going to add the deck. Okay, so obviously no one will be able to walk across that bridge and no one will be able to drive across that bridge because there's nothing to actually drive on. You go straight into the river. Okay, so we're just going to create the road or the deck of the bridge now. So to do that, we're going to use our friend the box again. Oh no, before we do that, we're going to move the work plane. So if we click on work plane, the work plane tool on the top right hand side of the component search bar again, we click on that and we're going to move that on top of the floor beams, or one of the floor beams, just like that. Okay, and then if we get our box, we'll drag that over just on top of the floor beam or the work plane, just like that. And then what we're going to do, we're going to change the dimensions of this block. Okay, we're going to change it to a height of 1 millimeter. Okay, we're going to change the width to 38 millimeters. Okay. And then we're going to change the length to 300 millimeters. Oh, just like that. Okay. Oh, no. As you can see, I've done that wrong. I changed the height to 300 millimeters. We want the height at 1 millimeter. Okay. And then the length. We want at 300 millimeters. Just like that. Okay. And then what we do, we'll drag that just into position, just so it's in the center of the two trusses or just touching the two trusses. Just like that. And again, just move around the work plane. Just have a little look around, make sure it's touching everywhere. And then we're going to change the color of that to gray because it's the road, and in general, we use tarmac or something along them lines. Okay, and then we'll move the work plane just to the bottom again. And there we go. We've created our bridge, okay? We've designed our first truss bridge in Tinkercad, and this is essentially how you would build, you would design anything in the bridge, design anything in civil engineering, whether that's a skyscraper, whether that's a house, whether it's a bridge, a road, anything along them lines. They will all be designed in this software, okay? Did everyone manage to follow on? I know it wasn't easy, this one. Really wasn't easy. I would like any input on whether I should simplify it for the future or is everyone okay?
Okay, teacher.
Excellent, brilliant. Okay, so while you're all completing that, I've just got something to show you. This is something a student has actually created, a little city. Okay, let me just find it. It's obviously disappeared from my, which is good, isn't it? Right, let me just log in again. I'll sign out and log back in again because it shouldn't have disappeared.
Galerinha, enquanto o professor tá achando a cidade que os alunos dele, os alunos fizeram, alguém tem alguma pergunta, alguma sugestão, quer falar alguma coisa para o professor dessa aula?
There we go.
I have a question. Can I make it? Professor, I'm looking at some school materials here. Can I make a bridge like this using, I don't know, pencils?
Yes.
Or
Yes, definitely. What I'll show you now, you can actually design the bridge. Let me just find it. If you just look at, well, wait for it to start up and I'll show you. You can actually design this bridge using popsicle sticks. Do you know what popsicle sticks are? Could you help me with that one, Diego, please? Popsicle sticks that you have lolly ices on. We call them...
O pauzinho do pirulito, gente.
We call them lolly ices, but I know everybody across the world don't call them lolly ices. So what we'll do, I'll change this to...
can I use the, I don't know the word, it's like
Pode falar em português.
palito de picolé.
Exatamente, o palitinho do pirulito ou o palitinho do picolé para fazer a ponte.
Tá, beleza. Thank you so much.
Sorry, what was that?
No, he was asking for the pop stick.
Ah, right. I'm trying to find where they are. Just give us 1 second. You can actually design them in it, and I'm just trying to find it.
With pasta as well, right, Professor?
What's that? Sorry.
Pasta.
Oh yes, the spaghetti challenge.
Yeah, I remember when I was at the uni, and my professor made us to build one, and then he went on top of that, and if the bridge breaks down, you fail. Oh.
That's it. And you spend hours and hours and hours building it, and then you just come along and destroy it.
Lord.
Yeah. Yes, but that it's an ideal example of what will actually happen when you're actually designing these things. That's what you need to do. You basically need to test them to destruction using software like this, essentially, so you know that you're 100% sure that will not it will not be destroyed, essentially, or will not collapse under load. So if you have a look at my screen now, you'll see like a little bit of a cityscape that a student has created just using the basic shapes that we've been using. So you've got spheres there, you've got cones, squares, all the different shapes. And as you can see, it's really, really, it's a really, really nice design there actually. And I was really impressed by it. It takes me weeks to do something like that. So yeah, so it's really, really good. Let me just see if I can find find these popsicle sticks so you can see. Come out of this. Has anybody else got any questions while I'm doing this? And on anything at all? Anything at all? So for the student to ask where we could find them, the popsicle sticks in the search bar or the component search bar there, you'll see where it says basic shapes. If you just click the drop down box and you can see making at home. Okay, if you just click on making at home, there you go. There's all household objects. So you can actually design something using household objects. And so if I just bring a popsicle stick over to the work plane, there we go. So you can actually build it just using these, okay? Which is really, really, again, a really, really, really good piece of part of the software, if I'm honest. So I'll just change the orientation of that to 45, and I'll also change it to another 45.
Sorry, Carl, can you show it again where they can find those do it at home kind of things?
The so the home, yes, no problem.
Yeah, the t-shirt reel and the pops. Yeah.
Yeah, no problem. So if I just go back to the basic shapes again. So if you just have a quick look at my screen now, and you'll see on the right hand side where all your shapes that we've been using, or the one shape we've been using, is you'll see a text box or a drop down box just above the shapes with basic shapes, or whatever the alternative is in Portuguese. Okay, you will drop the drop down box just like that, and you will be faced with a number of different parts collections, they call them. Okay, and you will see a selection called making at home. Okay, so if you just click that making at home, and you will see in the component search bar, you've got everything from popsicle sticks, tissue rolls, paper towel rolls, pencils, everything from pennies, everything you've basically got at home. So you can design anything that you want out of household objects in Tinkercad and then build it yourselves at home, which is really, really good. Okay.
Yeah, this is pretty cool, actually.
Camila is going to build one, Professor.
I'm going to try to do one. Yeah, it's not going to work out, but I will try it for sure.
This software is, I've used this software many times with students in the UK, and it's absolutely fantastic to use. A lot of you actually click the classes option, join a class option. I used to actually set homework for my students using that, and essentially if they were having problems at home with it, I could log in and basically fix it for them in their workspace. So it's really, really good. It's a really good piece of software, I should say. Okay,
fantastic.
So I truly do hope everybody enjoyed that, and I know it's a challenge, okay, and I really do appreciate it's a challenge, but again, just have a go, just keep tinkering, do what the name suggests, keep tinkering, keep playing with it, okay, and you will get it down. All right. So has anybody got any questions for me?
Teacher, the pasta bridge, it's really possible, or it's just a...
Yeah. Well, you will if you go into civil engineering. If you decide to choose to study civil engineering, you will build a pasta bridge. You will build a pasta bridge. It won't be obviously it won't be a full size bridge, but it will be a bridge to scale, they call it. So you will like we've scaled our bridge down. So essentially 10 meters, what is it? 10 millimeters is 1 meter, essentially. That's our scale. So you will actually build this spaghetti or the pasta bridge to scale, and as your teachers just said, you will test it to destruction as well. So someone will come along and either stand on it or they will put an immense amount of weight on it, and they will break it just to see how far they can push the bridge before they actually break it. But again, have a go at building this one in pasta and see how much weight you can actually place on the bridge before it collapses. And then after you've done that, try different shapes of bridges, try different just try it yourself, build bridges in different formats, maybe join the two trusses together at the top, which is a really, really important part, which we've missed off. Okay, join the bridge, join the trusses at the top. So do one where you haven't joined the top, and then do another one where you have joined the top, and see the difference in the weight that it can actually hold. You'll be very surprised the difference in the weight it can hold. Another thing that you could possibly do, build one without the diagonal members. If you build one without the diagonal members and just build it with square blocks, again, see how much difference, the difference in weight you can actually place on it. It will shock you at the difference in the weight it will actually hold. Okay. Anybody else?
Okay, I really try to do this. Thank you.
No problem at all. Again,
So-
it's not easy, and I do appreciate that. So just keep on trying.
Just one comment here. Pessoal, se vocês fizerem, se vocês tentarem fazer com algum material de casa, igual vocês podem ver aqui no site que vocês conseguem, mandem uma foto pro Diego e ele consegue encaminhar para a gente encaminha para o professor também para ele ver, né? E aí ele pode até fazer os comentários dele em cima, mas é legal para a gente saber que vocês também estão tentando fazer isso em casa.
Bem bacana. Galera, olha, a gente está aí, já passamos 1 hora de aula. O professor ele tem as outras coisas dele para fazer, a Camila também. A gente aproveitou bastante. Quem tiver dúvidas, galera, pode mandar por e-mail. Eu vou passar meu e-mail aqui de novo, que eu encaminho para o professor e ele vai responder cada pergunta para vocês, tá? Não se preocupem. Professor, I just want to say thank you very much. I personally enjoyed this. I missed a lot my classes. So thank you very much.
No problem.
Yeah, so the students, so Camila was asking for the students, if they try to do this at home, they can take a photo and send to me so I can forward to you guys.
Brilliant.
Amazing.
Excellent. And also, sorry, I just interrupted you.
That's okay.
If you do expand on this and build if you decide to go to build a city, please share that with me as well. I'd love to see it.
Muito legal, gente. Olha, foi muito bacana o dia de hoje. Só não deixem de esquecer, gente, que eu comentei com o professor que isso conta muito pro portfólio de vocês, tá? E aí, peraí, professor. Sorry, professor. We got one student here. She is very enthusiastic here. If we did some diagonal stringers underneath the bridge, making contact with the river bank, would be stronger?
Yes, it would. Yes, it would. And you will find that does actually happen as well. Okay, it all depends on the actual length of it. Also, what you will find, where we've actually formed the floor beams at the bottom, you will find that will be a truss as well. Okay, so you will have diagonal braces across the floor beams as well, and that will basically stop the bridge from trying to pull itself apart. Okay, but these are all things that you can experiment with. All right, I've left them out on purpose just so you can experiment with it, and then if you do decide to build these out of pasta or popsicle sticks, you can then add these extra things, and you can see how much it actually increases the capacity of the load capacity of the bridge, or how much weight it can hold. Okay, so this is for where you can start experimenting yourselves now.